Hello, dear friends. Welcome back to GRM Doppers classes. Dear friends, in the last class, we have completed our discussion on the definition of angle and the measurement of angle and different systems of units of measurement of angle. And in this session, let us go for the trigonometric ratios of an angle, dear friends. So let us see what are called the trigonometric ratios and what are the relations and identities among them. Let us see now. Dear friends, as we know that when the initial ray of an angle lies along the positive x-axis with the vertex at the origin, the angle is said to be in the standard position. So according to the terminal ray, when it lies in first quadrant, it is said to be in the first quadrant. When terminal ray lies in second quadrant, dear friends, it is said to be, that means the angle is said to be lies in second quadrant. And like that, we have seen angle in different quadrants. Now, dear friends, whatever the angle here, what actually called the trigonometric ratios of an angle, and what are the properties and identities of the trigonometric ratios? Let us discuss now. Now here an angle theta lies in the standard position. Let this is the terminal ray of the angle. Wherever it is, no problem. Either it is in first quadrant or second quadrant or third quadrant or in fourth quadrant. Suppose this is the terminal ray of an angle theta, and Px comma y is a point on the terminal ray of the theta at the distance r from the origin. At the distance r from the origin, which is not 0 here. Because when r equal to 0, Px comma y will be the origin only. Therefore here, Px comma y has been taken not at the origin. Means that r not equal to 0. So dear friends, when Px comma y is a point on the terminal ray of theta, then different ratios of x, y and r can be defined. Different ratios of x, y and r. That means ratio of any two of these three can be defined. So those ratios are called trigonometric ratios, my dear friends. Actually, ratio of any two letters of this, two terms of this r, x, y are called trigonometric ratios actually. These are regarding angle theta here. And here, the ratio y by r is called sine of theta, S-I-N-E. The ratio y by r. When an angle theta lies in the standard position, if Px comma y is a point on the terminal ray of theta at the distance r, which is not 0, then the ratio y by r is called sine of theta. Whereas the ratio x by r is called cosine of theta. The ratio y by x for x not equal to 0. Dear friends, sometimes this x may be 0. Depending on the angle, I will tell you where this x will be 0 and y will be 0. So I will tell you. But here, when x is not 0, the ratio y by x is called tangent of theta. And the ratio x by y for y not equal to 0. Of course, sometimes this y may be 0. Depending on the angle. That's why provided this y not equal to 0. the ratio x by y for y not equal to 0 is called cotangent of theta, dear friends. And the ratio r by x for x not equal to 0 is called secant of theta. SECANT, secant of theta. And the ratio r by y for y not equal to 0 is called cosecant of theta, dear friends. Like this, different ratios of x, y, and r can be defined as the trigonometric ratios. Out of these three, any two can be taken, and out of those two, you can take the ratio of them in two ways. For example, when r and x are taken, you can define x by r as well as r by x in this manner. X by r, r by x. So like this, 6 trigonometric ratios will be possible, which are here y by r is called sine of theta, SINE, x by r is called cosine of theta, y by x is called tangent of theta for x not equal to 0, x by y for y not equal to 0 is called cotangent of theta, r by x for x not equal to 0 called secant of theta, and r by y for y not equal to 0 is called cosecant of theta, my dear friends. And here, of course, shortly these can be written as, because we cannot write the full word, shortly this can be written as sin theta. Can be written as sin theta, read as sine theta, which is y by r, cos theta, x by r, tan theta, which is tangent of theta, but shortly can be written as tan, like this, and read as tan theta. This is cos theta, which is x by r, tan theta, y by x for x not equal to 0, right? And cot theta, which is cotangent of theta, shortly can be written as cot theta, which is x by y for y not equal to 0. Here secant of theta shortly can be written as sec theta, which is r by x for x not equal to 0, and cosecant of theta can be written as cosec theta, shortly can be written as this and read as cosec theta, which is r by y for y not equal to 0. Dear friends, when px comma y lies at the distance r from the origin, you know what is the distance of p from the origin? Root over x square plus y square will be equal to r. Means here r equal to root over x square plus y square. Then what is r square? R square will be x square plus y square. So that is the relation between r, x and y. R square equal to x square plus y square. So because of the sine theta equal to y by r, because sine theta equal to y by r and cos theta equal to x by r, from the definition of sine theta and cos theta, you can write this x equal to r cos theta, taking r on this side, x equal to r cos theta, comma y equal to r sine theta. Hence the point P can be taken as r cos theta, comma r sine. So this will be most useful point in two-dimensional geometry. Sometimes you need to find the coordinates of a point. Coordinates of a point on the line passing through the origin, inclined at an angle theta, can be taken as r cos theta, comma r sin theta, dear friends. So you please remember this one as well as. So this is the point x comma y at the distance r from the origin on the line inclined at an angle theta with the positive x-axis. Like that, point x comma y can be taken as r cos theta, comma r sin theta. Okay, friends. So from these definitions, you can observe some points here. You can make some observations. What are they? Let us see now. Tan theta can be written as sin theta by cos theta. Why? Because sin theta is y by r, cos theta is x by r, cancelling r, tan theta can be taken as y by x. That you can see from here. So tan theta is y by x, no? Y by x is called tangent of theta. Here shortly you can see this tan theta equal to y by x. which is sin theta by cos theta, y by x. So tan theta is now sin theta by cos theta. And cot theta is cos theta by sin theta, just taking the ratio of cos theta and sin theta. So that will be equal to cot theta here. You can see that x by y, which is nothing but x by r by y by r. So cot theta is cos theta by sin theta, dear. And here tan theta and sec theta are not defined at theta equal to plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, so on 2n plus 1 pi by 2 for all n belongs to z. Why? Because tan theta is what? Y by x. Sec theta is what? R by x. Means both tan theta and sec theta have same denominator, x. So that those two will not be defined when x equal to 0. That means x should not be 0 to define tan theta and sec theta. But here, when theta is either pi by 2 or 3 pi by 2, you know, from this one. So when you rotate this one and theta is equal to pi by 2, what happens? Here, terminal ray comes along the positive y-axis, where x equal to 0. Again, rotating by 3 pi by 2, terminal ray comes along negative y-axis, where x equal to 0. Therefore, when this terminal ray comes along either positive y-axis or comes along negative y-axis, the x-coordinate of this point P becomes 0, where the ratios in which x comes in the denominator will not be defined. Therefore, dear friends, tan theta and sec theta are not defined when x equal to 0, means that when theta equal to pi by 2 or 3 pi by 2 or 5 pi by 2, 7 pi by 2, like that. Okay, friends. So these are not defined. These are not defined when x is equal to 0. Yes, like that. Even taking the rotation in clockwise direction, what happens? When theta equal to minus pi by 2, theta equal to minus 3 pi by 2. So for all this, x coordinate becomes 0. Hence, this tan theta and sec theta are not defined for theta equal to plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. For any odd multiple of pi by 2, this tan theta and sec theta are not defined. The same way, cot theta and cosec theta will have same denominator y none. Means that cot theta is x by y, whereas sec theta is r by y. Are not defined for theta equal to plus or minus, theta equal to plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, so on. Any multiple of pi for all n belongs to z. Because when theta is either 0 or pi or 2 pi or 3 pi, 4 pi, like that, this terminal ray comes along either positive x-axis or negative x-axis. Therefore, in both the cases, y coordinate of this point px comma y becomes 0. When the terminal ray comes along any of these x-axis, either positive or negative. That's why in the case when the terminal ray comes along the x-axis, cot theta and cosec theta will not be defined because y coordinate gets 0. Y coordinate will be 0, dear friends. Hence, we can say that cot theta and cosec theta are not defined for theta equal to plus or minus pi, plus or minus 2 pi, plus or minus. Plus means in counterclockwise direction. Rotation in counterclockwise direction. Minus means rotation in clockwise direction. Therefore, for any multiple of pi, this cot theta and cosec theta are not defined. And one more thing, you can also See here, when theta is any multiple of pi, because y is 0, sine ratio will be 0. Sine ratio will be 0 because sine theta is y by r. So that will be 0 for y equal to 0. Therefore, for all these angles, dear friends, for all these angles, sine theta will be 0. When sine theta is 0, tan theta will be also 0. Why? Because tan theta is sine theta by cos theta. So for all these angles, sine theta will be 0. Whereas for all these angles, cos theta will be 0. Why? Because cos theta is x by r. Now for all these angles, x coordinate becomes 0. X coordinate will be 0. So that cos theta will be 0 because cos theta is x by r. When cos theta is 0, cot theta will be 0 because cot theta is cos theta by sin theta. Like this, you can see the values of tan theta and cos theta for all these values. Okay. And if okay, let us see now. And also one more point here, sin theta into cosec theta will be 1. Why? Because sin theta is y by r, cosec theta is r by y. So the product is 1. Means that they are said to be reciprocal of each other. Means that sin theta equal to 1 by cosec theta and cosec theta equal to 1 by sin theta. So like that, you can say sin theta into cosec theta is 1 from the definition itself. From the definition only, the sin theta into cosec theta equal to 1. So that they are said to be reciprocal of each other. Similarly, cos theta into sec theta is also 1, dear friends. Because cos theta is x by r, sec theta is r by x. So that product will be 1. Hence, these two also said to be reciprocal of each other. Now you can see here, cos theta is x by r, whereas sec theta is r by x. So that product is 1. Hence, these two are said to be reciprocal of each other. Sin theta, cosec theta. Sin theta is y by r, cosec theta is r by y. So that product of these two is also 1. Hence, these two are reciprocal of each other. Similarly, tan theta is y by x, cot theta is x by y, when both x and y are non-zero. When both x and y are non-zero, tan theta is y by x, cot theta is x by y. Hence, the product of these two is also 1. So that these two also said to be reciprocal of each other, dear friends. Therefore, you can simply remember that sin theta into cosec theta is 1. Sec theta and cos theta is 1. They are reciprocal of each other. Cot theta and tan theta is 1. So that they are reciprocal of each other, my dear friends. Okay. Now, coming to one more observation here. The sin square theta plus cos square theta can be taken as sin square theta plus cos square theta is y square by r square plus x square by r square according to the definition. So that it is x square plus y square by r square. X square plus y square by r square. But what is r square? Just now we have seen r square is x square plus y square. So that it can be taken as r square by r square. Otherwise, x square plus y square by x square plus y square. Anyway, both are same. When both are same, ratio is 1. Hence, dear friends, sin square theta plus cos square theta is always 1. Then, sin square theta can be written as 1 minus cos square theta, which is 1 minus cos theta of 1 plus cos theta. Similarly, cos square theta can be taken as 1 minus sin square theta, because taking sin square theta on the right side become minus. So cos square theta equal to 1 minus sin square theta, which is equal to 1 minus sin theta of 1 plus sin theta. Then also you can see the secant square theta minus tan square theta. So from the definition, secant square theta is r square by x square minus tan square theta is y square by x square, which is equal to r square minus y square by x square. What is r square? X square plus y square minus y square become x square. X square by x square is 1. Therefore, secant square theta minus tan square theta equal to 1, dear friends. These are all very, very important observations. All important identities of trigonometric ratios, my dear friends. Based on this only, this whole trigonometry will be dealt. So that you must remember all these identities very well. So then only you will become perfect in this chapter. So dear friends, the secant square theta minus tan square theta equal to 1. Then secant square theta can be written as 1 plus tan square theta, taking tan square theta on the right side. Otherwise, tan square theta can be written as secant square theta minus 1. Or the secant square theta minus tan square theta can be written as sec theta plus tan theta into sec theta minus tan theta. Sec theta plus tan theta of sec theta minus tan theta. So because the product is 1 again, so these two are said to be reciprocal of each other. These two are said to be reciprocal of each other. Means if sec theta plus tan theta is, for example, 1 by 2, then sec theta minus tan theta will be 2, which are reciprocal of each other. So that product will be 1. So in that way, this is also another pair of reciprocals. Similarly, dear friends, coming to another observation, cosecant square theta minus cot square theta. So this cosecant square theta, according to the definition, is r square by y square minus cot square theta is x square by y square. Cosecant square theta is r square by y square. Cot square theta is x square by y square, which is r square minus x square by y square. But r square equal to x square plus y square. So x square plus y square minus x square become y square by y square equal to 1. Hence, cosecant square theta minus cot square theta equal to 1 when both are defined. In the same way, you can write it as cosecant square theta equal to 1 plus cot square theta, taking cot square theta on this side. And the cot square theta can be taken as cosecant square theta minus 1. Or, so this cosecant square theta minus cot square theta can be written as cosec theta plus cot theta of cosecant theta minus cot theta. Because this product is also 1, these two also can be taken as a pair of reciprocals. That means one is the reciprocal of the other, dear friends. So like this, you have totally 7 identities I have taken here. Of course, from this you can go for some other identities also. But here, just you can see once again, tan theta is sin theta by cos theta, whereas cot theta is cos theta by sin theta. Here itself, you can see that product is 1. Tan theta into cot theta is 1. Okay. Anyway, sin theta is tan theta is sin theta by cos theta, and cot theta is cos theta by sin theta. Now here, tan theta and sec theta are not defined for odd multiples of pi by 2, because for odd multiples of pi by 2, x coordinate becomes 0, because terminal rail comes along positive y axis. Hence, tan theta and sec theta are not defined for x equal to 0. X equal to 0 is nothing but y axis. Therefore, angle along y axis will not define tan theta and sec theta. Similarly, cot theta and cosec theta are not defined for y equal to 0. Y equal to 0 means x-axis. X-axis means angles can be either pi, 2 pi, 3 pi, 4 pi, and so on. So for any multiple of pi, tan theta and cot theta and cosecant theta are not defined. And then sin theta and cosecant theta are reciprocals because product is 1. Cos theta and sec theta are reciprocals because product is 1. Tan theta and cot theta are reciprocals because product is 1. Okay, that means cosecant theta is 1 by sin theta. Sec theta is 1 by cos theta. Cot theta is 1 by tan theta. The similar way, sin square theta plus cos square theta is 1. So that you can transform in another forms. So secant square theta minus tan square theta is 1. Otherwise, sec theta plus tan theta into sec theta minus tan theta is 1. You can see the identities. And cosecant square theta minus cot square theta is also 1. Otherwise, cosecant theta plus cot theta into cosecant theta minus cot theta is also 1. So dear friends, like this you have some identities, otherwise properties of trigonometric ratios. Now let us come to some definitions here. When theta is in the interval 0 to pi by 2, that means theta is just more than 0, less than pi by 2. Pi by 2 means 90 degrees. When theta lies in the interval 0 to pi by 2, means in the first quadrant. Means in the first quadrant. When theta lies in the first quadrant, or when theta lies in the interval 0 to pi by 2 or 0 to 90 degrees, then theta is said to be an acute angle, lies in the first quadrant. Acute angle always lies in the first quadrant because this is the interval of first quadrant. Similarly, when theta lies in the interval pi by 2 to pi, means 90 degrees to 180 degrees. But here 90 degrees to 180 degrees is what? Angle in the second quadrant. So when angle lies in the second quadrant, it is said to be an obtuse angle here. When theta is in the second quadrant, means either pi by 2 to pi or 90 degrees to 180 degrees, then theta is said to be an obtuse angle. Lies in the second quadrant. Obtuse angle always lies in the second quadrant, dear friends. And then, when sum of two angles, when A plus B equal to pi by 2, here A and B are two angles. So when sum of two angles is pi by 2 means 90 degrees, then A and B are said to be complementary angles. When sum of two angles is 90 degrees, they are said to be complementary angles. And when sum of two angles is pi or 180 degrees, then angles are said to be supplementary angles. So like this, we will define certain terms like acute angle, obtuse angle, complementary angles, and supplementary angles according to the angle here. Okay. Now let us go to the sign of a trigonometric ratio. That means what will be the sign of a ratio for the angles in first quadrant, for the angles in second quadrant, third quadrant, and fourth quadrant. So depending on the angle, that means depending on the terminal ray where it lies. So what will be the sign of a trigonometric ratio? Let us discuss now. So from the definition, dear friends, when angle lies in the first quadrant, means when angle, that means in first rotation, you can have 0 to 90 degrees. In second rotation, 360 to 450 degrees. That means 2 pi to 2 pi plus pi by 2. So like that, for any number of rotations, if the terminal ray comes in first quadrant where x, y, and r, of course r will be taken always positive because r is the distance from the origin to the point. Now here the sign depends on the sign of coordinates x and y. But when angle lies in the first quadrant, whatever the amount of angle, either it is after one complete rotation or two complete rotations or three complete rotations, any number of rotations, if the terminal ray comes in first quadrant, so here all the ratios will be positive because all the terms x, y, and r will be positive. Therefore, here all the ratios will be positive. Whereas in second quadrant, in second quadrant, so here x coordinate becomes 0. Here r and y will be positive. R will be always positive. Here y also positive, but x is negative. Hence, the ratios of r and y only will be positive. Ratios of r and y means either y by r or r by y. So when ratio contains x, when ratio consists x, so it will be negative because x coordinate is negative. Hence, in the second quadrant, only sine ratio and its reciprocal cosecant ratio will be positive, whereas the remaining will be negative, dear friends. Because in the second quadrant, both r and y will be positive, but x will be negative. Hence, the ratios of x will be negative, whereas ratios of y will be positive. So ratios of y are what? Y by r and r by y, means sin theta and cosecant theta will be positive in second quadrant, whereas the remaining will be negative. Whereas in third quadrant, both x and y are negative. Hence, the ratio of x and y only will be positive. Otherwise, if the ratio of rx, otherwise ry, because only x or y will be there, so the ratio will be negative. Hence, ratio of both x and y only will be positive in third quadrant. That is the reason why tan theta, which is y by x, cot theta, which is x by y, will be positive in this third quadrant, whereas the remaining four ratios will be negative. Either with x coordinate only or with only y coordinate, the ratio will be negative. Whereas the ratio of both x and y, though both are negative, the ratio will be positive. Hence, tan theta and cot theta will be positive in the third quadrant, whereas the remaining will be negative. Coming here. So, because in fourth quadrant, y will be negative, x will be positive. Hence, the ratio of r and x only will be positive, whereas the ratio of r and y or x and y, x and y. So, when you have y in the ratio, that will be negative because y coordinate is negative. So, without y, that means ratio of r and x only, either x by r or r by x. The ratios will be positive. Hence, cos theta and sec theta are positive, whereas the remaining are negative. Therefore, in first quadrant, all are positive. In second quadrant, sin and cosecant, sin theta and cosecant theta are positive. In third quadrant, tan theta and cot theta are positive. In fourth quadrant, cos theta and sec theta are positive. So, depending on the definition of sin theta, definition of trigonometric ratios, dear friends, so that is only the reason we can go for any definition. So here we must be very careful about the definitions of trigonometric ratios. Based on that only we will define all the properties of trigonometric ratios. So here all the ratios are positive in first quadrant, sin and cosecant only positive in second quadrant, tan and cot only positive in third quadrant, cos and secant only positive in fourth quadrant. So like this you will have sign of trigonometric ratios in different quadrants. Now coming to another important point about sign of the trigonometric ratio of a negative angle. Negative angle means, so when theta is one angle, its negative angle is minus theta. So like that, what will be the trigonometric ratios of minus theta? Let us discuss now. In this case, for example, when theta lies in first quadrant, so minus theta lies in fourth quadrant in this manner. Because, so minus theta is the same amount of angle as with theta, but in clockwise direction, when theta is positive. Okay. Otherwise, when theta is this one, minus theta is this one. When theta lies in fourth quadrant, then minus theta lies in first quadrant. In that case, theta will be negative, minus theta will be positive. So anyway, I have taken theta in the first quadrant, then minus theta will be in the fourth quadrant. Okay. But to compare these two, we should consider one point x comma y on the terminal ray of theta, and another point at the same distance as theta should be considered on the angle minus theta, terminal ray of minus theta. That means, see, this is the point at the distance r from the origin, and this is also the point at the same distance from the origin, r. So when this point is x comma y, then this point will be x comma minus y because of symmetry about the x-axis, r distance. So that for every point at the same distance, so these 2 points will have that means opposite y coordinates. When y is positive here, y is negative here. Like this, points will be taken on theta and minus theta. Also, when theta lies in second quadrant, so minus theta of same amount but in clockwise direction will be taken in third quadrant like this. When theta lies in second quadrant, minus theta lies in third quadrant because of same amount of angle but opposite direction. Opposite direction means when this is counterclockwise, this is clockwise direction. So even here also, the points at the same distance will differ by only y coordinate. That means sign of y coordinate. Coordinates will be same. So why? Because coordinates are nothing but directional distances. So that we will discuss in coordinate system. But dear friends, here it is. When this is the point x comma y, means this is y coordinate, this is x coordinate. Distance from y axis is the x coordinate. Distance from x axis is the y coordinate. So when this is x comma y, so this point will be x comma minus y. That way, when point P on the terminal ray of theta is x comma y, point at the same distance on the terminal ray of minus theta will be x comma minus y. So because of this point, you can say sine of minus theta means sine ratio of minus theta you are defining. Sine ratio of minus theta. What is that? It's y coordinate by r. But what is the y coordinate? Minus y by r. This is minus y by r. So that minus y by r can be taken as, minus y by r. This is not x. Let me check it. Yeah, just a minute. Yeah. Okay, friends. Now here, sine of minus theta. Sine of minus theta, according to the definition, can be taken as its y coordinate. Y coordinate of minus theta by r from the origin to point. That is minus y by r. Now separating minus, you can write it as y by r. But what is y by r for theta? Y by r for theta is sine theta. Hence sine of minus theta is minus sine theta from this transformation. Sine of minus theta is y coordinate of minus theta by r. What is y coordinate of minus theta here? Minus y. So minus y by r, which is minus of y by r. So that it is minus sine theta. So that when sine of minus theta is minus sine theta, reciprocal will be also having same sign. So cosecant of minus theta will be minus cosecant theta. Because cosecant of minus theta is 1 by minus sine theta, 1 by sine of minus theta. 1 by sine of minus theta is minus 1 by sine theta. Minus 1 by sine theta is minus cosecant theta. So whatever one ratio has the sign, its reciprocal also will have the same sign. Therefore, when sine of minus theta is minus sine theta, cosecant of minus theta is minus cosecant theta. Similarly, cos of minus theta is what? According to the definition, cos of minus theta is the x coordinate of minus theta. What is the x coordinate of minus theta here? X only. X by r is the definition of cos of minus theta. So, but what is x by r for theta? X by r for theta is cos theta. Hence, cos of minus theta is cos theta only. Therefore, secant of minus theta will be sec theta. Because secant is the reciprocal of cos theta. Hence, whatever this cos has the sign, so the same will be for secant. Cos of minus theta is cos theta, whereas secant of minus theta will be sec theta. Means that minus will not come out of the cos ratio. And here, minus will come out of the sine ratio. Minus will come out of the sine ratio, but minus will not come out of the cos ratio. And here, tan of minus theta from the definition can be taken as minus y by r, minus y by x. So that minus y by x can be taken as minus y by x. But y by x for theta is tan theta. Hence it is minus tan theta. So tan of minus theta is minus y by x, which is minus of y by x. But y by x for theta is tan theta. Hence it is minus tan theta. So tan of minus theta is minus tan theta. Otherwise, you can go for sine of minus theta by cos of minus theta. Sin of minus theta is minus sin theta. By cos of minus theta is only cos theta. So minus sin theta by cos theta become minus sin theta, minus tan theta. So in that way, using these two ratios also you can write this ratio tan of minus theta. Otherwise, from the definition of tan ratio also you can say tan of minus theta equal to minus tan theta. Implies cot of minus theta will be minus cot theta because cot is the reciprocal of tan. Cot of minus theta will be minus cot theta because tan of minus theta is minus tan theta. So like this, we will have trigonometric ratios of negative of an angle. Finally, you can see this sin of minus theta is minus sin theta. Cos of minus theta is cos theta only. Tan of minus theta will be minus tan theta. That means except cos and its reciprocal. So for the remaining 4, minus will come out of the ratio. That means minus of the angle will come out of the ratio. Sin of minus theta is minus sin theta. Tan of minus theta is minus tan theta. But cos of minus theta is only cos theta, dear friends. And also the reciprocals will follow the same rule. Like this, you will have trigonometric, that means sign of the trigonometric ratios of negative angles. Then, when theta is acute, so it will be an angle in a right angle triangle OPQ from this diagram. See, when theta is acute, terminal ray lies in the first quadrant. When theta is acute, terminal ray lies in the first quadrant, dear friends. When terminal ray lies in the first quadrant, you can take one triangle like this where PQ is perpendicular to the x-axis. Where PQ is perpendicular to the x-axis. So this is one right angle triangle. Right. Then according to the definition of coordinates, so this PQ distance will be the y coordinate. OQ distance will be the x coordinate. Because distance from x-axis is y coordinate, distance from y-axis is x coordinate. Here both x and y are positive now. When theta lies in the first quadrant, every point in the first quadrant will be positive, so that both x and y are positive. In that case, this x and y can be taken as the sides of a right angle triangle in which theta is an acute angle. Theta is an angle. Theta is an acute angle. So in this case, here y is opposite side of theta, x is adjacent side of theta. Length of the adjacent side of theta is x. Length of the opposite side of theta is y. So that y can be taken as opposite side of theta, x can be taken as adjacent side of theta, where r is the hypotenuse of this right angle triangle. R is called hypotenuse of this right angle triangle. Therefore, this x, y and r will be sides of the right angle triangle OPQ, my dear friends, when theta is acute. In that case, dear friends, sin theta by definition, which is y by r, sin theta by definition, which is y by r, can be taken as opposite side by hypotenuse. Because this y is opposite side to theta, can be taken as opposite side by hypotenuse. Whereas cos theta by definition, which is x by r, cos theta by definition is x by r, where x is adjacent side to theta and r is the hypotenuse. So that cos theta can be taken as adjacent side by hypotenuse in the right angle triangle OPQ. And here tan theta, which is y by x, can be taken as opposite side by adjacent side, and cot theta, which is x by y, can be taken as adjacent side by opposite side. Here opposite side by adjacent side, which is tan theta. Cot theta is the reciprocal of tan, can be taken as adjacent side by opposite side. Dear friends, here sec theta is by definition r by x, which is hypotenuse by adjacent side, which is the reciprocal of cos theta here. And cosec theta is r by y by definition, so can be taken as hypotenuse by opposite side, which is the reciprocal of sin theta here. So like this, when theta is acute angle only, can be taken as the sides of a right angle. That means will be defined as the ratios of sides of a right angle triangle in which theta is one angle. But these are not the definitions of trigonometric ratios for any angle, for all the angles. So these are the definitions only when theta is acute. Means these are the definitions only for acute angles. Why? Because acute angle can be taken as one angle in a right angle triangle, so that trigonometric ratios can be defined like this: sin theta as opposite side by hypotenuse, cos theta as adjacent side by hypotenuse, tan theta as opposite side by adjacent side, cot theta as adjacent side by opposite side, sec theta as hypotenuse by adjacent side, cosec theta hypotenuse by opposite side in a right angle triangle, and theta is one angle. Here always y is the opposite side of theta, x is the adjacent side of theta. So like this you can define the trigonometric ratios of an acute angle. Trigonometric ratios of an acute angle, taking that acute angle as one angle in a right angle triangle, you can define the trigonometric ratios in this manner, my dear friends. But these are not the definitions of trigonometric ratios in general. In general, definitions are different what we have studied in the beginning, but here these are the definitions only for acute angle in a right angle triangle. Okay, friends. So with this, we have completed the definitions of trigonometric ratios and relations and identities among them. Okay, so I hope you have understood everything of this discussion today, of this session today. So let us go for one more session, finding the trigonometric values of certain angles, finding the trigonometric values of certain angles, certain standard angles. So I will come with that video as soon as possible. But before that, dear friends, please share this video to all your friends as much as possible, and also subscribe this channel, so which gives you more important information, important content, which helps you in your preparation. So dear friends, so don't forget to share, and don't forget to subscribe this channel, so which will be definitely helpful to you. So dear friends, let us stop our discussion here and continue in the next session. Till then, have a nice time. Okay, friends? Yes.